Already we discussed about secondary treatment. In that we discussed suspended culture system and attached culture systems. In the attached culture systems, there are the systems that are practiced usually trickling filter, rotating biological contactors, biotowers. Okay, anyhow, as I told you, I focus on trickling filter. Now we can learn how to design trickling filter. Before that, get into design of trickling filter problem. First, we have to understand the design parameters. So, coming to the design parameters, these are the characteristics: conventional or low rate trickling filter, or standard rate or conventional or low rate trickling filter, one and same, high rate trickling filter. Okay, coming to that first parameter, characteristic, depth, usually in the conventional or low rate or standard rate 1.5 to 3 meters, high rate 1.2 meters, 2 meters, hydraulic loading 1 to 4, 10 to 40. Units we have to understand here, meter cube per day per meter square, which means meter cube per day per meter square area, 1 meter square area. 1 meter square area, hydraulic loading, flow rate, hydraulic loading that can be accepted, that can be treated 1 to 4 in the conventional standard rate trickling filter, and high rate to 10 to 40, which means that this is the trickling filter. Let us assume in case circular trickling filter, this is the surface area. So for meter square area, let us say that this is the meter square area. In this meter square area, that can that can accept the hydraulic loading rate 1 to 4 in standard rate and 10 to 40. That is the meaning of these units. Units are most important. Coming to that organic loading rate, this is 80 to 320 and 320 to 1000. The units are gram per day per meter cube, which means that this is the BOD. This is the BOD. In 1 meter cube of the volume, this much of gram per, this much of 80 to 320 gram per day, that can be treated in 1 meter cube. Whereas coming to that high rate trickling filter, 320 to 1000 gram per day in 1 meter cube. That can be treated. That is the meaning of this hydraulic loading rate. This is the organic loading rate, BOD. Recirculation usually not required in the conventional or low rate or standard rate trickling filter. High rate trickling filter, it is mandatory. It is to be provided. Here we have to remember these parameters while we are designing the problem, designing the trickling filter. We have to remember these parameters. Okay, friends. Coming to that design of a trickling filter, first problem. The sewage flows from a primary clarifier to a standard rate trickling filter at a rate of 5 mld million liters per day, having a 5-day BOD of 150 mg per liter. Determine the depth and volume of the filter, adopting a surface loading rate 2500 liters per meter cube per day and an organic loading of 165 gram per meter cube per day. Also determine the efficiency of the filter using NRC formula. Okay. Coming to that solution, here the total, first you have to find out the total BOD per day. Total organic matter per day. That is equal to total flow equal to 5 mld. 5 mld means 5 million liters per day. Means we have to convert into the liters. That is equal to 5 into 10 to the power of 6. That gives the liters per day into BOD. BOD equal to 150 mg per liter, that is converted into the 150 gram per liter, so that 10 to the power of minus 3 into the coming into the picture. So therefore if you simplify this one, you can get 7,50,000 gram per liter BOD. Total BOD per day 7,50,000 gram per day BOD is to be get into the filter. Okay, coming to that, if you simplify these units, I have converted the 10 to the power of 6 mld liters per day. So the milligrams converted to the gram per liter. So that is the 10 to the power of minus 3. So therefore, if we cancel that liters and liters, so that we can get the gram per day. Okay, 1 mld equal to 10 to the power of 6 liters. Okay, next volume of the filter. Volume of the filter equal to total BOD by organic loading rate. Total BOD by organic loading rate. So already we found out the total BOD, that is equal to 7,50,000 gram per day divided by total organic loading rate is given in the problem. This is a 165 gram per meter cube per day. That is a 165 gram per meter cube per day. Gram per meter cube per day. If you simplify this one, we can get 4,545.5 meter cube. You see that the units gram per day divided by gram per day into, if you take up in the numerator, meter cube per day divided by gram, so that if you cancel that gram and day and day, you can get meter cube. Like this we can get the volume of the filter. Next, coming to that surface area, total flow divided by hydraulic loading. These are the things you have to remember. How to get the volume, BOD, total BOD divided by organic loading. Surface area is related to the total flow divided by the hydraulic loading rate. So total flow equal to already 5 mld, that is converted into the meter cube, that is equal to 5 mld into 10 to the power of 6 liters. So 10 to the power of 6 liters. So if you want to convert it in the meter cube, 1 meter cube equal to 1000 liters. We know that. From this we have to, coming to this, 5 into 10 to the power of 3 meter cube per day divided by hydraulic loading rate 2500 liters per meter square per day. You coming here, that is the 5 into 10 to the power of 3 meter cube per day. This is the liters converted into the meter cube. 1 liter 1 meter cube equal to 1000 liters. So therefore 2500 going to come there. If it is converted to meter cube, that is 2.5. So therefore, if you simplify this one, we can get 2000 meter square. You see here simplification units, meter cube per day into meter square into day divided meter cube cancel, day cancel, you can get the meter square. So these are the units cancellation, you have to understand. So now we have volume and we have surface area. So obviously you have to get the volume of the filter, total BOD by organic loading rate, surface area, total flow divided by hydraulic loading. So volume of filter and surface area we found out. Volume of the filter equal to 4545.5 meter cube, surface area equal to 2000 meter square. So from these two parameters we can find out depth equal to volume by surface area, that is equal to 4545.5 meter cube divided by 2000 meter square. From this, if we cancel these two, we can get 2.27 meters. So therefore the surface area equal to pi d square by 4. It is a circular section, circular filter, so that surface area equal to pi d square by 4. From this, if you take out d, surface area into 4 divided by pi, root surface area into 4 divided by pi. If you substitute surface area into 4 and pi, if you simplify this one, you can get to 50.5 meters. That is the diameter of the filter. As per NRC, efficiency of the filter E equal to, there is a formula, National Research Council USA recommended this equation, this formula, 100 by 1 plus 0.44 root organic load. This organic load is substituted in the form of kg per day per meter cube. So E equal to 100 divided by 1 plus 0.44 root 0.165. If you cancel this one, if you get 84.88%. Organic load equal to, we have organic load in the problem is given 165 gram per day per meter cube, that is converted into the kg per day per meter cube, that is equal to 0.165. that is substituted here. We got 84.88% of this filter efficiency. Thank you.